we can I'm starting with ionic bonding. So it's a bond between two atoms. One is a metal and second is a non-metal, and it is normally a case. In A level, it's never a rule that it's always a metal and a non-metal, and they give out a ionic bond always. Bond in A level is a relative character. In every ionic bond, there is some covalent character, and in every covalent bond, there is some ionic character. It measures between a metal, a non-metal. What are the factors? What are the factors that affect the strength of an ionic bond? You can look at the screen. Yes, please go ahead.
Oh, yeah, the size of the ion, basically the radius, right?
Ionic radius and ionic charge, factors that affect the strength
Yeah.
of an ionic bond, ionic radius and
But like,
ionic.
was it if it's smaller, it pulls, it has a stronger pull, right?
If it's a smaller size of ion, two things will happen. Number one, initially the bond will be very strong. Secondly, a small positive charge will distort the large negative, and gradually the ionic character shift to covalent character, the polarization effect.
Okay.
What is the trend down a group? As ionic radii increases, ionic charge decreases. They're also isoelectronic. So what's the trend in the row? Ionic charge increases, ionic radii decreases. What is a covalent bond? It's a bond between two atoms in which the electrons are shared. Do you remember there are two types of covalent bonds, sigma bond and pi bond?
Yeah.
Okay, there's a sharing of bond. And what is a dative covalent bond?
It's basically the sharing of an electron pair.
The electron pair is shared by one atom alone. Okay.
Yeah.
What's the metallic bond?
Metallic bond is the bond found in metals,
And
which
it
is
is
between electrons and
positive ions
ions, positive ions, sorry.
and surrounded by delocalized electrons, sea of electrons.
Yeah.
Then the topic which is always in discussion, and a lot of people work on that when the exams are closed. Every student marks the topics which the student feels that they are difficult for him. Like normally mechanisms are being discussed. I was thinking to put a separate class, quick revision class, that we can revise all the mechanisms. We just like we are discussing now, nothing to write, just like a discussion. Okay. And mechanisms are there, shapes of molecule are now coming up. Also, I was thinking about mass spectrometer. This is another topic which should be recalled. And meanwhile, if you are doing the yearly paper, you can find the queries. And I hope you are checking the marking scheme as well as examiner reports. Molecular shapes. You can see the molecular shapes here. The first shape I'm discussing is linear. The linear, for example, carbon dioxide. What is the bond angle?
180.
And what is the electron pair repulsion theory?
It's between a lone pair of electrons. They repel more than a bonding pair. Basically, lone pair repulsion is the highest. Then is
Right.
lone pair bond pair, and then there's bond pair repulsion.
Okay, and you remember that concept that the electron pair repulsion theory says that the repulsion between the electron pairs rearrange the molecules such that the repulsion becomes minimum. What is trigonal planar? It's 120 degree. There is no lone pair. If there is no lone pair, the example is BCl3 and the bond angle will be 120 degree. Now look at this trigonal pyramid. When the trigonal pyramid comes, when
When there's
There is
one lone pair.
one lone pair. Very good. And if one lone pair is present, will it decrease the angle?
Yeah.
It will decrease the angle, and the angle decreases here.
To 107.
Tetrahedral. There are four bonded pairs.
Tetrahedral. Yeah.
Mhm.
Yeah, I was gonna say this thing, the wedge is out of page and the other one dotted lines inside page, right?
Very good. And
Okay.
then if we move for bent shape is specially famous for water. There are two lone pairs. 104.5 is the bond angle, and this is again a very famous molecule. Trigonal bipyramidal. Look at this shape. The molecule is molecule is 3D, and the bond angle is 120 and 90. Why there are two bond angles given here?
In which one? In trigonal bipyramidal, because
Yes.
that's the two angles
Why
that
there
it
are
makes.
two bond angles?
It's the two separate angles that are formed.
It's basically one is actually one chlorine, this one and this one. Look at this angle, and then this chlorine and this chlorine, the bond angle is 90.
Yeah. That's 90, then the one inside outside page is 120.
Right. Acha, then octahedral. Octahedral is another shape. When we expect octahedral to come, the shape octahedral, when the shape, this shape comes,
Six bonds. Six bonds. Normally sulfur.
bonding electrons, 6 bonding
Yeah.
pairs.
Yeah. But 6 bonding pairs would mean a total of 12 electrons, no?
But there is no lone pair, right?
Yeah, no lone pair.
Comes another topic, which is always, this is another topic from this chapter, which is always in discussion. Molecular shape. What determines the molecular shape? There are two important factors: the number of lone pairs and number of bonding pairs. Order of repulsion. Lone pair repulsion is always the maximum, and bonding pair repulsion is the least one. What is electronegativity as a concept?
Basically, it's a number that shows you like the power it has to attract.
In a bonding system,
Yeah.
every atom attract the shared pair.
Yeah.
Every atom has a shared pair of electrons, has an attraction for the shared pair of electrons. This attraction capability is called electronegativity. It's a scale, it's a number.
Okay.
Who is the most electronegative element?
Fluorine.
Okay. And then this concept, many people normally forget about this in paper, that in A level, bond is not an absolute character. Bond is a relative character. For example, a very famous example, AlCl3. It's a metal, non-metal. AlCl3, is it a ionic compound or covalent compound?
AlCl3 is covalent.
Yes, very good. Even though it's a metal, non-metal, so it was expected that it should be an ionic bond, but it is not ionic. Why it is not ionic? Look at this concept.
Which one? Is not ionic.
The arrow.
Yeah. Ionic character is low.
Ionic character is
Ionic
character is gradually shifting as the
Okay, so
difference in electronegativity is increasing. As the difference in electronegativity is decreasing, the ionic character in percentage is changing. So when the electronegativity difference is 0.1, the ionic character is only 0.5. But when the electronegativity difference reaches 3, look at the ionic character has reached 89%. There are two important there are two important outfit of the molecules, polar, non-polar. How we identify polar, non-polar molecules? Like water. Water is a famous polar molecule. How we know from the shape, from the structure here, that water is a polar molecule? Is it regarding the dipole-dipole cancellation?
yeah.
If the dipoles cancel each other, then look at this example. CO2 is polar, non-polar.
CO2 is non-polar.
And water,
This is polar.
so what's the difference? Is it regarding the shape? Yes, can you please reply? It is the game of the shape. If the dipoles cancel out each other, the molecule is non-polar. Even the bonds can be still polar. If the dipoles do not cancel out each other, like a physics concept of balancing the forces, if the dipoles do not cancel out each other, the molecule will be polar. Definitely, the bond should be polar. What is a bond polarity? You can always look at the screen for a quick recall. Bond polarity and molecular polarity are different things.
Yeah, bond polarity would be specific to bonds, obviously. But
So
then,
if I summarize, if I make a summary and we discuss it here, the polarity of a bond is due to difference in electronegativity. The polarity of a molecule is due to the shape, right?
yeah.
So now look at these three examples. HCl polar, CHCl3 chloroform is polar. Why CHCl3 is a polar molecule? And why is CO2 we already, can you tell me why this molecule is non-polar?
Because all of them cancel out. Because they're 90 degrees basically. So they all just cancel each other out.
So all the dipoles do not cancel out.
No, they do cancel out. That's what.
So some polarity left over.
No.
No, they are. Look at this arrow now.
Is it? Okay.
It's a physics rule now. Look.
No, but then there's inside of page, there's outside of page. So like those two would cancel out.
No,
And
just
then the
like
ones.
you take physics also. Now let me show you a rule. And you can easily recall. Now tell me this. Is it balanced?
Oh, right. That's an HCH. That's why it's,
There
yeah,
is
okay.
a polarity figure here. One polarity, second polarity, third polarity. This bond, CH bond, is nearly what? CH bond is nearly
Non-polar.
non-polar. Good. What are intermolecular forces? Are they attraction forces between molecules? How many intermolecular forces are there?
Van der Waal.
Van der Waal forces. Van der Waal forces, are they also called London forces induced in
Yes.
instantaneous dipole? Second is
Yeah.
permanent dipole. And third is,
Hydrogen bonding.
you can always look at the screen.
It wouldn't induced dipoles also be a thing, or
The third one.
yeah, but then induced dipoles, wouldn't that be a thing as well?
No. Third is hydrogen bonding.
Yeah. Yeah.
So now one by one, what are these London forces? Instantaneous dipole. It's a temporary dipole which shift like a wave. When a ripple comes in water, temporary water molecules jump here and there. It's a temporary dipole which swings like a flash, and this is instantaneous. Is it right that van der Waal forces are always there? They are permanent forces between every type of molecule. These forces are present.
Yes,
Good.
technically.
Acha, what's a permanent dipole?
Permanent dipole is
Look
the
at this.
dipole between bonds, like the bonds, yeah. So two
What's a
polar
permanent dipole?
molecules.
If a
Two,
molecule is polar,
yeah, so
if a
two polar
molecule is polar,
molecules.
the unlike polarities, like the in physics, the unlike charges attract each other. This is a permanent dipole. Hydrogen bonding is very important. What are hydrogen bond forces? These are, look at this arrow, These are hydrogen bonding. These are hydrogen bond forces.
Yeah.
Are they really strong forces? Can you tell me now what is the hydrogen bond? Is it necessary that hydrogen bond involve hydrogen?
No.
Yes. The name,
Yes. All
Shahid,
right.
name, hydrogen bonding. That is definite. Na? If it is hydrogen bonding, hydrogen must be a permanent player. Look at this diagram, very famous. Can you identify what molecules are here?
Water molecules.
Water molecules. There are hydrogen bond forces between water molecules. And remember this sentence, the last sentence. Look at this. They are the strongest. Hydrogen bond forces are the strongest.
Okay.
Intermolecular forces, this is my next point of discussion, controls melting point, boiling point, and solubility. If intermolecular forces are strong, melting point, boiling point are high, right? If hydrogen bonding is present, that substance will be soluble in water. If hydrogen bonds are available, if hydrogen bonds are present, these hydrogen bonds enable the molecule substance to dissolve in water. So can you repeat for me that hydrogen bond forces control MP, BP, and solubility? How they control it? In what sense?
In what sense? The bond energy that it requires to break it?
But if the hydrogen bond forces are strong, will they increase MP, BP?
Yeah.
Good. And what about solubility? For example, there was a question, ethanol is soluble in water, even it is organic, but it is soluble in water. Why ethanol is soluble in water? Why?
Because of
Because ethanol
weaker
molecules, please go ahead.
Weaker hydrogen bonds.
Yes, perfect. Good. I'm continuing this point. High melting boiling point. So the strong hydrogen bond forces result in ice having a much low density structure. Now, trends in the properties. Now, these are very important trends. As the length of an alkane chain increases, the boiling point increases, and there are more points of contact with each adjacent molecule, stronger LDFs, London dispersion forces. Straight chain alkane will have a boiling point higher than a branched one. Alcohols can form hydrogen bonds as well as London bond force. Achha, London forces, van der Waals forces are permanent forces. So these are few important trends. Solvents. Polar, dissolve, polar. Non-polar, dissolve, non-polar. Solvation. Alcohols have the OH group and therefore can form hydrogen bonds. That is why alcohols are soluble in water. There are two, I'm discussing now the structure. Ionic, actually, there are total 3 structures, right? Or 4 structures. Can you recall for me the structures? Ionic, simple
Ionic,
molecular.
simple molecular, giant covalent, and metallic.
Very good. And fourth one?
Metallic, is it?
Metallic. Very good. Very impressive. Good. Perfect. So there are 4 structures. Okay. First, we talk about ionic, metal and non-metal, and they have a lattice structure. Look at the block here in the revision section here. Look at the block. Ionic structures have high melting. Many are soluble in water, conduct electricity when liquid, and they are brittle. They can't withstand any heat. What about simple molecular? Simple molecular like Cl2, Br2, nitrogen, helium, etc. Sorry, not helium, form with covalent bonds, and they have low melting point. Some are soluble in water and does not conduct electricity until they are in a special liquid form. Otherwise, they are not conducting electricity. Metallic bond, a very famous structure. Electrostatic attraction between metal ions and the delocalized electrons. Billions of ions held together in a giant lattice of cation in sea of delocalized electrons. The greater the group charge, group charge, the greater the attraction. Metals, is it right? Metals are all good conductors of heat and electricity.
Yeah, most.
And why I
All of them.
underline this word? Why metals are good conductors of electricity? Because they contain.
Delocalized electrons.
Very good. Acha, what is malleability?
Malleability is where you can basically shape the metal into different shapes, not shape like
Slide over, no?
bend it in. Yeah,
Like
because of
you can make aluminum foil
yeah, because of the layers inside it that
because
can
of the
slide over
layers.
each other.
The layers can slide over. Acha, giant covalent and allotropes of carbon. First, what is a giant covalent structure? Is it a macromolecule? Yes, please go ahead.
Yeah, sorry. Which one?
Is it, what is
Diamond?
a giant covalent structure? Is it a macromolecule?
Yes, could be.
Good. And they're all covalent. So graphite, graphene, and diamond. They were in our O level also. So you can always look at the screen. What is diamond?
Diamond is a giant allotrope. An allotrope of carbon. It's a
And
giant covalent
do you remember
structure.
this? Do you remember this word?
Tetrahedral.
And you remember, right, that there is always an issue when EDEXCEL papers are there. People have to follow a good quality of language. Star one is always there, but overall you have to follow a good strong language. For that, I'm always expecting and reminding you that do view some examiner reports. Everyone is doing that if they have to get a very good result in unit one, and obviously unit one will support the results in other units. So if you make a marking scheme, everyone is looking, that's fine. But examiner reports are very helpful. And I think I told you, if you can try to get some scripts, that I have shown you some examiner reports in which student response was there. So you can, if you have if you are suppose going to school tomorrow, you can ask your teacher, because they have it always, the latest ones, 2022, 23, if they can share with you, though we can discuss there. It's a very helpful booklet which shows that what examiner is actually looking for. What are the A grade students? What are the C grade ones? What are the E grade ones? They're very helpful. Diamond has a high melting point and it doesn't conduct electricity. Look at this underline. Why diamond or why anything is not a conductor of electricity? What would be the rule?
There's no free delocalized electrons.
Yes, there are no mobile charge carriers. There are no mobile charge carriers which can transfer the electricity. Good. Acha, now come to graphite. What's the difference between graphite and what is the difference between graphite and diamond?
Graphite is still an allotrope of carbon, but it has I think it has delocalized electrons, right? Or is that
Between the
these?
layers.
Yeah. And these layers can also slide over each other. I think these layers can slide over each other. I'm not sure.
Sorry,
I'm saying I think the layers can
slide over.
slide over each other.
Very good. Just like we can slide our hands on each other. Perfect. Acha, graphene is, even it's an O-level topic, it doesn't come much, but many people forget about it. Graphene is a special type of allotrope, like a man-made one. And look at the properties: high melting boiling point and good conductor of electricity. Graphene is much stiffer, much stable than graphite. Graphite and graphene, they both are conductor of electricity. So we did this quick revision. So I'm doing some questions here. This is June 15, Unit 1. As I told you that my plan, that I will be doing topical revision and questions with you. We will try to revise the whole course, and it will be a good flashback, which everyone helps. You have to tell me, and I have to recall the notes, important points with you, and then we should do some questions. I'm also planning to do some quizzes with you so that we can see our timing, because the last thing which has to be improved is the time. It's a single paper and the time constraint should be addressed. Now, read the question and answer.
The greatest ionic character would be in the smallest anion and the largest cation, or is it the other way around?
It depends upon the character, na?
Yeah, so like largest cation, which one was it?
Think again.
Smallest cation, I'd say. And I think it's potassium iodide. I'd say it's potassium iodide, not sure.
Potassium iodide. Why?
The largest anion and the smallest cation.
Yes, a small positive ion is capable of distorting a large negative. Number 91. Which species has a dative covalent bond?
Dative covalent should be H3O because it has a positive charge.
Because the reaction shows here recalls that actually H plus is a proton which is not stable. So H plus need resistance from H2O. It takes the lone pair from water and it forms a dative covalent bond. So answer, you have selected it right, A. The atomic radius of potassium is larger than that of sodium because potassium has potassium and sodium, are they in the same group? You can keep the periodic table with you.
Okay. Yeah. Potassium is larger than sodium. Potassium has um more occupied electron shells.
If potassium and sodium are in the same group, they won't be having different number of shells.
No, they're in the same group, but there's more occupied shells in total.
So if we go down a group, do you remember that number of shell increases? Is it right?
Yeah. Yeah.
Good. Number of shell increases, so radius of potassium is larger than sodium. Why? Because compared to sodium atomic number is 11. So 281. An example of potassium 19, 2881. So potassium has 4 shells and sodium has 3 shells. So what should be the answer? C.
Yeah, should be C.
Right. This question is about the elements aluminum and magnesium. Complete the electronic configuration of an atom of aluminum. You can keep the periodic table with you. Aluminum is group 3. What is the atomic number of aluminum? Yes, please reply.
Yeah, Al3 plus, right?
But what is the atomic number of aluminum?
Atomic number of aluminum is 13.
13.
Yeah.
So 1s2.
Yeah.
Is this?
One is two. Wait. So that's 10 electrons. Yeah, should be. Yeah. Yeah, that's correct.
Can you solve part B now?
So in Al3 plus, proton number will stay the
What is the mass
same.
number of aluminum in the periodic table?
27. So proton, there's 14 of them. Oh, sorry, 13 of them. 13 protons, 14 neutrons, and 10 electrons.
Proton is how much? 13,
Yeah, should be.
right? And 14. What about electron? The charge is plus 3. 3 electrons have already gone.
Yeah, so 10.
Right. Now this one. The table below shows the first 4 ionization energies of aluminum. Complete the table by identifying the orbital from which each electron is removed. This is the configuration.
3s2 and 3p1.
First one will be going from 3p,
1.
and then it should be 3s, again 3s. Can you notice a huge jump?
Yeah, that's between 3s and
Cell
then
changes?
going into 2p6.
Very good. I just have to write 2p, that's fine. 2p6 is fine.
Yeah.
Write the equation including state symbols will represent the second IU of aluminum. So do you want to tell me or want to write it?
Well, this is just Al gas and then a plus 1 charge already, then turns into Al2 plus G gas plus E minus. So it goes from +1 to +2. That's about it.
This one?
No, this would be the third ionization energy, no?
Okay. Then
Al
be
plus 1.
this one.
Yeah.
Star question, asterisk one. Explain why the second I of energy of an element is always greater than the first I.
Because there's a shift. Well, this is second electron, so it destabilizes the atom even more. Therefore, it requires more energy.
But was it a concept that after the loss of one electron, the nuclear attraction per electron or effective nuclear charge increases.
Effective nuclear charge increases.
What was the concept? Just like in an atom, you have lost one electron. Okay, the first one, the second and first. If first IE means electron is lost. If one electron is lost, nucleus is in its same position. So do you think nuclear attraction per electron will increase? For example, in aluminum, there are 13 electron and 13 proton. The nucleus contains 13 plus, and outside there are 13 electrons. I have taken out one electron. Now there are 12. So per electron, for every one electron, will it be more attraction by the nucleus?
Yeah, so there's a greater nuclear charge, therefore.
Greater nuclear charge. So what is the concept? Actually, what happens? Actually, what happens that nuclear attraction increases because initially the nucleus was capturing 13 electrons. After the loss of one electron, the same nucleus has to cater 12 electrons. So nuclear attraction per electron increases. This one, number 4.
Why is it much larger?
We have discussed it here, na? This
Because
one.
there's a shift in subshell,
Yes, the level
or
energy level
the
changes
energy level changes, so it requires more energy
because you are now taking electrons out from an inner level.
from a different quantum level, quantum shell.
Aluminum is a silvery metal with a melting temperature of 933. He says it's a metal, right? Draw a label diagram of the bonding in aluminum. So can you tell me, can you draw and or copy draw and you can share with me? I'm just coming, draw this diagram. So can you suggest the structure?
Right.
Can you suggest the structure?
Metallic, basically positive ion, cations, and then
But how we used
electrons
to
around
draw
it
it, because we,
in arranged layers. Yeah, it's not.
this one,
Yeah,
then
small electrons around it. Yeah.
this is a structure of delocalized electrons. The atomic number of magnesium is one less than the aluminum. Would you expect magnesium to have a higher lower melting point than aluminum? Justify your answer. Magnesium is 12, aluminum is 13.
Yeah. So I would expect aluminum to have higher melting temperature because
Magnesium is a metal and aluminum is also a metal.
yeah.
Please give the answer. Magnesium has only one electron in the outermost shell. Aluminum can have 3 electrons in the outermost shell. The game is the number of free electrons. So magnesium has less free electrons in the lattice, while aluminum has more free electrons in the lattice. So aluminum lattice will be stronger than magnesium lattice.
Okay.
Then
To be 7x's around each chlorine.
like this.
Yeah, that would be fine. Yeah.
No, I'm actually waiting for you. That is it the right one I should do, or should I go for the other one? The
No, it should be this one, like
because this is
Mg.
metal and non-metal.
So it should be this one, with the
Very good. I was waiting for that because
plus
magnesium
2
chloride is more ionic. Magnesium chloride is more ionic, less covalent.
yeah, -1, sorry. -1, right? Yeah.
Mg is +2.
EL. This is yeah. Yeah, Mg +2.
Asterisk question. Aluminum chloride has more covalent character than magnesium chloride. And you remember, I think you have drawn this before, again, before also. The physical properties of two chlorides suggest one piece of evidence showing that aluminum chloride has more covalent character than magnesium chloride.
Okay. It means physical properties.
Ionic compounds have higher MPBP compared to covalent. So it means aluminum chloride must be having lower MP than magnesium chloride.
Yeah, and I was gonna could we say the overlapping of orbitals is not allowed?
Overlapping of orbitals.
Okay, so overlapping of
Do you
orbitals.
remember the dative bonding? But he's not asking for any structure. He's asking for evidence.
Right.
So what evidence will be there? That the lower melting point, boiling point, which ion has the largest ionic radius? Negative ion is bigger than the source atom. Positive ion is always smaller than the source atom. And you have to look again the periodic table. Are they in the same period? Or they are in different periods?
CA is in the same period as K, but not CL and S. CL and S are in different periods. The largest ionic radius would be CL minus.
Why see? Positive
Or would
ion is
it?
always.
No, but it says largest, not smallest, right?
He says largest. Please reply quickly.
Should be CL minus, I'm thinking. But it could be S2 minus as well.
Because you have to keep the periodic table in front of you.
Yeah, CL and S2 are in the same period. CA and K are in the same period. It can't be actually no, it should be S2 minus because it has the least amount of uh, protons. So
No, actually,
less
you just have
states.
to see a periodic table and you have to see calcium, chlorine, potassium, S minus 2. In a period left to right, the radius changes. So, I will explain it next time, but somehow you can remember this. Now it's a period game. You have to keep the periodic table in front of you in a period left to right. The radius decreases. And when you make a positive ion, you get a smaller ion. And when you get a negative ion, you get a bigger ion always. Anyways, we did some questions today and we will do it inshallah in the next class. Okay. Thank you.
Okay, office.
Hafiz.